to expand upon what I talked about in the last lesson, specifically working with cell potentials. And so really quickly as a review, the half cell potential is always going to be listed as the reduction potential. And remember, if you want to determine the cell potential for something that's being oxidized, you simply take the negative of the reduction potential. And the last piece of information, which is the only new thing that I'm introducing in this lesson, is if a reaction is multiplied by a coefficient, you do not multiply the cell potential. This isn't really an issue yet because we haven't worked with some concepts where you do multiply or raise values based on coefficients, but for these, you ignore the fact that you are multiplying them by a coefficient. So let's look at an example. So to determine the cell potential for an overall reaction, which includes oxidation and reduction, all you do is you take the cell potential for oxidation and add it to the cell potential for reduction. So let's determine the electromotive force for this reaction that's given to you. And so my first task is to determine what's being oxidized. Well, since sodium is going from an atom to an ion, a positively charged ion, that means it lost electrons. So I have sodium, and it's going to produce sodium ions. And I've got to make sure I add that electron there because it's losing one electron. Now, fluorine's being reduced. Fluorine is going to become fluoride. And I got to keep in mind that I'm adding 2 electrons to create that fluoride ion. And so my next task when I'm balancing this is to make sure that my electrons are balanced like what we did previously. So I've got to take the sodium and I've got to take that entire oxidation reaction and multiply it by 2. So have 2 electrons there, 2 sodiums there, and 2 sodium ions there. Now I'm going to look up the cell potential for sodium and for fluoride. Well, the cell potential for sodium is actually the reduction potential. So I find the reduction potential and I'm simply going to flip the sign. So it was negative 2.71 for reduction. Well, since this is oxidation, I'm going to take the negative of that. So it's positive 2.71 volts. Then I'm going to look it up for fluoride, and it is positive 2.87 volts. And so all I have to do to find the standard electromotive force is add those together. So I get positive 5.58 volts. Now keep in mind, I multiplied all of the sodium reaction by 2, but I didn't change the cell potential for that. I didn't multiply it by 2 or anything. So make sure that you're not multiplying by coefficients. And that's all there is to it. Making sure for oxidation that you flip the charge. So if it's positive, make it negative. If it's negative, make it positive. And otherwise, just sum them together.